Shubham? Shubham?
Yes, ma'am.
Okay, so what we have done last time in last lab, can you tell?
Ma'am, we were doing about PSK.
Okay, so last time we have completed the PSK experiment. Okay, and with that we have also completed the digital modulation techniques. Right, so three techniques were there for the digital modulation: ASK, FSK, and PSK. So till now we were telling it as a digital modulation because our data was digital. Right now, next we are going to study is analog modulation, in which we are going to study only one of the technique which is in your syllabus, that is the amplitude modulation. Okay, so in your lab, one of the experiment of the analog modulation is also included, and that is amplitude modulation. Ravi, ma'am, can you revise short about PSK? Okay, Ravi, just let me tell you that we have studied phase shifting, in which if we are sending the binary data, that is 0 and 1, then we are sending two different phases. That is, one is the 0 degree and one is 180 degree. Okay, so you can assign one of the phase for the one digital data, and another phase to the another digital data. But if it is multi-level, that is more than two numbers, right, not my binary, then we have also seen one of the technique is QPSK, quadrature phase shifting, in which we require four different phases. And for that we have also seen the constellation diagram, if you remember. Right, in that constellation diagram we have seen that how the four different phases will be assigned to the different levels. Right, for 0 0 0 1 1 0 and 1 1, four codes we are having, and for those four codes we have assigned the four different phases to each. Okay, so here our phase is the one which will carry the information, which will carry the data, digital data, not amplitude, not frequency. Okay, so in like in ASK and FSK, either amplitude was carrying the data or frequency was carrying the data, but here the phase will tell you that what is the data, what is the binary data, either it is 1 or 0. Right, so phase of the signal will define the information. Rest of the parameter of the signal are not the information, are not required at all. Okay, so phase is very important in this phase. So PSK, that we have studied, and if you want to know more about it, then you can refer the PPT which is already uploaded in Canvas. I think that will be enough, right, Ravi? Yeah, okay, fine. So today we are going to study analog modulation. Just a minute, guys. Okay, so we were discussing that today we are going to see the technique for the analog modulation. Now we will think that when we will use now analog modulation technique. So let me tell you that if you are having the data information as an analog signal, right? But whatever data you will have, that will be the physical parameter, right? For example, the let's say whatever I'm talking, right? That is the acoustic waves. If you will convert this acoustic waves into the electrical signal, that will be the analog waveform, right? And that analog waveform will be of very low frequency. Okay, so whatever frequencies we are generating in the real life is of low frequency, and whenever I want to send my voice to the long distance, right, then this voice cannot travel a long distance. Let me give you the example that, for example, you are in a classroom, you are speaking something, then your acoustic waves can travel in a class only. Or let's say if your voice is a little bit loud, then you can send it to up to two classes, right, but not more than that. So if you want to send your signal to the long distance, then one thing you can do is you can increase the volume, right? That is, you will amplify the strength of the signal. That is the one thing. But let me tell you, whenever you will amplify the signal, the strength will be increased, but the frequency is very low. And it is being proven in the communication that very low frequency signal cannot travel a long distance, right? And why it will not travel a long distance? Because frequency is inversely proportional to the time. So if frequency is very low, then time is very high, right? So one cycle will occupy so much time, right? Time period for one cycle will be very large, and this cannot travel a long distance because time and distance are again related with each other, right? So it is from the mathematics it is being proven that low frequency signal cannot travel a long distance. So what we can do is, second thing we can do is we can increase the frequency of the signal. But how? Our data is having a specific frequency, and at the receiver side also we want that frequency only. If we will increase the frequency, maybe data will be changed, right? So I don't want that. So what we are doing is we are doing the modulation process. In modulation process, again, same like digital modulation, we are choosing one of the parameter of the signal, either amplitude or frequency or phase of the carrier. Right? So we will introduce one carrier signal of very high frequency. I repeat, we will choose a carrier signal of very high frequency. So the amplitude of the carrier signal will change according to the our message signal, then it is known as amplitude modulation. Frequency of the carrier signal will change according to the message signal, then it is known as frequency modulation, FM. And if phase of the carrier signal will change according to the message signal, then it is known as phase modulation. So let me tell you, in digital modulation and analog modulation, the process is same. The only difference is in the digital modulation, the original data was digital, that is either binary or some multi-levels, right? But here, the original data, the information is analog. It means it is having an infinite values. So our carrier signal will follow those infinite values according to the message, right? So whatever information signal we are having, that will be followed by the carrier signal, either in form of amplitude or frequency or phase. And at the receiver side, the same signal will be demodulated. So here I am going to show you one of the modulation technique, that is the amplitude modulation. Okay, so let us start this. So you are able to see the PPT, right? Okay. So to perform amplitude modulation and demodulation using AM transmitter and receiver, and this is a type of amplitude, analog modulation techniques. Okay, so before starting, you everyone has one question in mind, that why modulation is required. Okay, so why modulation is required is given by a very beautiful animation in this video. So let us see this video before starting the session. Then I will tell you that which are the things mentioned in this video and how this modulation is done and what are the advantages and disadvantages. Just a minute. Okay, are you able to listen the audio here? Everyone, are you able to listen the audio? Okay, fine. So let me start it now.
Need for modulation. At the end of this lesson, you will be able to define modulation, explain the need for modulation. In the previous topic, you were introduced to the communication system. In this topic, you will learn one of the important processes used in communication system. It is modulation, which literally means change. Before heading to the topic, let us look at an analogy to understand the need for modulation. Do you think that you can throw a piece of paper to a distance of 5 to 10 meters? It is impossible because the paper is of less weight. At the same time, if you enclose a stone inside the paper, it can reach longer distance when it is thrown. This is because of the stone's weight. Stone carries the paper along with it. Here, we can compare the less weight paper to the low frequency message signal in the communication system. This weak signal cannot travel across longer distance without any loss. Hence, we will take the help of a high frequency carrier signal. By superimposing the low frequency message signal with the high frequency carrier signal, we can send the message over longer distances. One of the popular communication systems where the process of modulation is applied is in radio communication. Most of us have radio in our house, right? Radio gets the signals from the base station. The frequency of human voice signal ranges from 20 Hz to 20 kHz. These are low frequency signals. It is impossible to transmit these low frequency signals directly due to certain drawbacks. Let us see what are the problems involved in transmitting the low frequency signals directly. The first problem is the height of the antenna. In any communication system, for transmitting a signal, we need an antenna. For efficient transmission, the height of the antenna should be at least 1/4 of the signal wavelength. If we consider sending low frequency of 15 Hz, the wavelength is 20 kilometers. Then 1/4 of the wavelength is 5. Thus, we need to design an antenna with a height of 5 kilometers, which is practically impossible. The second problem is interference. If there is more than one base station in a city, then the signals with same frequency get mixed up with each other. The third problem is poor reception. As per the equation representing the energy of the electromagnetic wave, it is clear that the energy of low frequency signal is very low. On traveling across a longer distance, they become very weak. Another problem is the effective power radiated by an antenna. Theoretically, the power radiated from a linear antenna of length L is proportional to L by lambda whole square. This shows that when we transmit a message signal of longer wavelength, that is, of low frequency, the power radiated will be very small. The reason for all these problems is the low frequency of the signals. If the frequency is high, we can overcome all these problems. But how will we increase the frequency of the message signal? Actually, we will not increase the frequency of the message signal, but we will superimpose the low frequency message signal with the high frequency carrier signal. Hence, the characteristics, that is, amplitude, frequency, and phase of the carrier signal will be changed in accordance with the message signal. This process is called as modulation. Let us see how the problems in the transmission of the low frequency signals are overcome by modulation. To overcome the problem of antenna height, if a high frequency signal of 1 MHz is used, the height of the antenna will be around 75 meters, which can be achieved practically. To overcome interference, if the stations transmit high frequency signals like 2 MHz and 6 MHz, then their difference will be high, that is 4 MHz, and thus the waves will not mix with each other. To overcome the problem of poor reception, if the frequency of the signal is high, automatically the energy of the signal will also be high, and hence we can obtain a good quality signal at the receiving end. By using high frequency transmission, we can achieve high power radiation without changing the antenna height. Modulation helps us to replace the wired medium with wireless medium communication. Also, we can achieve a high range of communication by using modulation. So far, we have studied about modulation and the need for modulation. When the modulated signal reaches the receiver, it is necessary to separate the message signal from the carrier signal. This process of recovering the low frequency message signal from the modulated signal is called as demodulation. Now, let us solve a problem based on height of the antenna. Find out the height of the antenna required to transmit a voice signal of frequency 3 kHz. We know that for efficient transmission, the height of the antenna should be equal to lambda divided by 4. We can obtain the wavelength from the equation shown here. Thus, the wavelength is 100 kilometers. 1/4 of it is 25 kilometers. From this lesson, you have learnt about modulation, problems in direct transmission.
Okay, so everyone understood the need for modulation, why modulation is required. Anyone has any doubt in this video? Okay, no doubt. So let me tell you, they have given the very beautiful advantages of the modulation, and this is the question which are generally being asked in the exam also. That advantages of modulation or need for modulation, both will have the same answer, right? That the height of the antenna will be reduced, quality of the reception will be good, right? So interference will not be there. So whatever advantages you have seen in this video, all are the need for modulation, that we will see in this ppt also, right? That this can be one of the question in the exam and how you can write the answer. So yes, yes, anyone wants to ask something? Okay. So need for the modulation is main. I already told you that even if you are speaking in a frequency 3 kilohertz or up to 20 kilohertz, then also the height of the antenna, required height of the antenna will be in the kilometers. And have you seen the antenna height in the kilometers? It is practically not possible, right? It can be some of the meters, right? So to reduce the height of the antenna, you have to increase the frequency, because there is a direct relation by the equation. F, you have already seen, right? That frequency and the wavelength relation is F equal to C by lambda. And height of the antenna and the lambda relation is height of the antenna equal to lambda by 4. Okay, so that's why you can say that the height of the antenna is inversely proportional to the frequency. And that's why you have to keep your frequency high so that your height of the antenna can be low. A message signal cannot travel a long distance because of its low signal strength. Of high frequency or high energy signal called carrier signal will be used. High energy signal can travel to a larger distance without getting affected by the external disturbances, that we have already seen, right? That if you are having the low frequency signals nearby, let's say two antennas are there which are sending the low frequency signals, then they can easily mix it up, right? So interference can be more. But if you are using the modulation, then the high frequency signal will be there. So the difference between the frequency is such that you will not able to get the any distortion or interference in the reception. Modulation means to change. Yeah, we have seen this, right, in the video also. That modulation means we are changing this, changing the signal, changing the frequency of the signal. So first is avoids mixing of the signal. Second is increase the range of communication. Third is wireless communication is possible. Fourth, reduces the effect of noise. Five, reduces the height of the antenna. Right? These are the five important need for the modulation, everyone. You must know why these are the advantages. First is avoids mixing of signals. I have already explained you. Second is increase the range of communication. Increase the range of communication means the long distance communication. Okay, so if your signal is having the high frequency, then according to the equation of energy equation is directly proportional to frequency. So if frequency is high, energy is high. And if energy is high, it can travel a long distance. Very simple fundamental. Third is wireless communication possible, because wireless communication is the one which will work on the high frequency. So if you are using the low frequency communication, then you have to use the wired communication. But you want to use the wireless communication, then you have to go for the high frequency signal. Fourth is the reduces the effect of noise, right? So it is almost the same as the first one. But why it can be a different, because reduces the effect of noise means whenever you are transmitting the signal, then your signal is continuously attenuated in a transmission medium. But if the signal is having the high energy, then what will happen, even if the signal will be strength will be reduced, then also at the reception side you will not get the nil, right? But if your signal strength is very low and if it is attenuated through the transmission medium, then at the reception side you will not get the signal at all, right? So it reduces the effect of noise. And the five is reduces the height of the antenna, that is by the equation h equal to lambda by 4 we have already seen. Any doubt in the need for modulation, everyone? So the antenna height, I already explained, the antenna height should be approximately equal to the wavelength of the signal to be transmitted.
Ma'am,
Yes,
we are in new chapter.
yes.
Are we in new chapter?
It's a lab experiment, no? It's not a chapter. It's a new lab experiment. We are in a lab, right? We are not in a lecture today. Is it okay?
Okay, ma'am.
Okay.
Ma'am,
Uh,
then what did we, ma'am, in ASK and all, in that also we modulated the signal, yeah?
Sorry, Anmol, can you repeat your question?
Ma'am, in ASK and like FSK, in there also we modulated the signal.
Yeah, we modulated the signal, but in that case, our data was digital. Here, our data is analog, not digital.
Okay,
Okay,
ma'am.
so for digital data, we can use the technique ASK, FSK, PSK, and for the analog data, we can use the technique AM, FM, and PM. Otherwise, both are the modulation technique, but one is the analog modulation and second is the digital modulation. That is the only difference. And Ashish, which experiment? We have already seen the title. If you want a number, then let me tell you, it is the so see, we are not going in a sequence, we are going in a such a order so that it can collaborate with the theory portion also. Okay, so this is the experiment number 8, but total 5 experiments we have completed. This is sixth for you. Okay, we have completed 5 experiments. First is sampling, second PCM, third ASK, fourth FSK, fifth PSK, and this is the sixth one, amplitude modulation. And Ravi is asking some question, how supporting low to high and differencing. Some confusion between them in modulation. Ravi, can you unmute yourself and ask the question? I'm not able to understand what you have written. Is Ravi there? Okay. Okay, mic problem. That is okay. So let me recognize what you have written. How supporting low to high and differencing. I mean, you want to say that how low frequency cannot travel a long distance? Then okay, so you'll ask me after some time, right? Okay, so okay, fine. Let me complete this. Then you can ask the question even if you are not getting. Okay, so here one equation was given of the wavelength. Wavelength is nothing but the velocity by frequency. So it is also say that if you are taking the light velocity, then it is light velocity upon the frequency. So light velocity is fixed, that is 3 into 10 raised to 8 meter per second. And the frequency is, let's say, 20 kilohertz, because 20 kilohertz is the highest frequency in the voice. Whatever people are speaking is the with the highest frequency 20 kilohertz. So if you are taking, even if this example, then also the wavelength requirement is 15,000 meters. And if it is the wavelength requirement, then what will be the antenna height? 15,000 divided by 4. So 15,000 divided by 4 is the highest length, height of the antenna is required. Okay, so height of the antenna is in kilometer again. So if you will divide it by 4, 4 threes are 12, and 3 0 4 4 4 sevens are 28. So it is almost a 3.7 kilometer. It is 3.7 kilometers, right? So if it is 3.7 kilometers, then there will be a very difficult to design this wavelength. But now let us calculate the wavelength for the modulation. If you are doing the modulation in the signal, so let's say we are doing modulation of the 20 kilohertz signal with the carrier frequency. Some let's say, okay, here it is given as the example 200 megahertz is the carrier frequency, and your original message signal is 20 hertz. Okay, it is 20 hertz as written. So if you are superimposing your signal, even if it is 20 kilohertz, then 20 kilohertz will be superimposed over the 200 megahertz signal. So your frequency, if you, even if you will ignore this frequency, then also your frequency will be 200 megahertz. And in this case, your height of the antenna, requirement of the antenna will be 1.5 meters. Okay, if this is wavelength, then you can divide it by 4. Okay, so anyway it is in kilometer and it is in the meter. So height of the antenna will be very less. The requirement of the height of the antenna will be very less if you are doing the modulation. So this is the biggest advantage, that is the height of the antenna. But even if you are increasing the frequency, you will get all these advantages with it. You have done it only for the antenna height, but you are getting this many advantages by doing it, by increasing the frequency. So you're not increasing the frequency of message signal, you are superimposing carrier signal over message signal, same like the what we have done in the ASK, FSK and PSK. Okay, so we will see the technique also, that how we can do it. Now, so far, let me tell you types of the modulation. Generally, which type of modulations are being used in the different type of communication. So, overall, two types of communication are there. That is continuous wave modulation and the pulse modulation. In continuous wave modulation, continuous wave means analog wave, right? So it is nothing but your analog wave modulation. So analog modulation can have either the amplitude modulation or frequency modulation or phase modulation, and this together can also be considered as an angle modulation. In pulse modulation, two types of modulations are there: digital modulation and analog modulation. In digital modulation, we have already seen two types of techniques, PCM and DM, pulse code modulation and delta modulation. And in the analog modulation, analog pulse modulation, we are having PAM, pulse amplitude modulation, pulse width modulation, and pulse position modulation. That is not the part of your syllabus right now in the lab, at least, right? So you are not going to study this part. You have seen this one, you are right now you are looking at this one. And the another modulation is here. In this, another technique is digital modulation, but not the pulse, not for the pulse, digital data modulation. And for digital data modulation, we have seen the technique ASK, FSK and PSK. Now, what is AIM? What is amplitude modulation? So what actually done with the message signal by introducing the carrier signal in the amplitude modulation? So let us see that. In amplitude modulation, it defines as the process in which amplitude of the carrier wave is varied in accordance with the instantaneous values, or you can say the amplitude of the modulating signal. Amplitude of the carrier is varied in accordance with the amplitude of the modulating signal. So just a minute. So see this animation here. This is your signal wave, that is your modulating signal. It is known as message signal or information signal or modulating signal. This is known as carrier wave. If you will superimpose this carrier wave over the signal wave, then what will happen? You will get this frequency, but the amplitude of the carrier signal will vary accordance with the value of this signal. So can you see this? See, amplitude of the carrier signal will be high when this peak is there. Amplitude of the carrier wave will be low when this value is there. So you will get this type of signal. This is known as modulated signal or amplitude modulated signal, whatever you say, right? Just a minute, guys. Just a minute. Huh? Some important call is coming. Okay, sorry for interruption. Okay, let's start. Now, generated signal is called modulated signal. As I told you that whatever signal is generated after superimposing these two signals, the signal is known as AM wave. Okay, it is same like ASK. If you will see, it is same like ASK. The only difference is in ASK, it was a digital or binary signal, and here it is a analog signal, or any message signal can be there. Okay, so here the analog message signal is there, and the in ASK it was a digital signal. Carrier signal was same. In the ASK also carrier signal was analog of high frequency. Here also carrier signal is of analog and high frequency. Okay, and the superimposing signal will give you this type of amplitude modulated wave. Now, the envelope of the modulated wave has the same shape as the baseband signal. Yeah, let me tell you, this is also known as baseband signal. Modulating signal, baseband signal, message signal, anything you will call, this signal is known as that. Okay, so this is also known as baseband signal. So, baseband signal is having this shape. Now, if you will look at this AM wave, then envelope means what? The boundary, right? So if you will cover all the boundary, draw the signal, then it is same as the boundary of this signal is same as this. But this signal has two boundaries. One is the positive envelope and one is the negative envelope at the downside. Let us complete it. Okay, see here, this is the positive, this is the cycle which is starting from the 0 degree. So positive cycle first, then negative, again positive, again negative. But here it is opposite, negative cycle first, then positive, again negative, and again positive. So two types of envelope we are getting here. But let me tell you, these are known as sidebands also. This is known as lower sideband and upper sideband, lower sideband and upper sideband. But generally we are using the different amplitude modulation technique, like we are transmitting both of the sidebands together, or we can transmit only one sideband, no problem into that. But in the different application, different type of techniques will be used. So we will see in detail in upcoming slide. But this is they are saying that the envelope of the modulated wave, envelope of this wave is having the same shape as this signal, message signal. Okay, so why it is required that envelope should have the same shape? Because at the demodulator side, right, at the reception side, we will use a demodulator in such a way so that it can detect this envelope, so that you can get the original signal back, right? So if the demodulator is able to detect this envelope, then you will be able to get the original signal back at the reception side. Now, let us see one animation. Just a minute. Wait for a minute. It is just a demo. Just I want to show you that how amplitude modulation animation you can see by using the different message signal. It is see, we have already seen in the OpenLearn website for the ASK, FSK, PSK, right? Same way, your academo.org website is there, where you can see the demo of the amplitude modulation by choosing the different message signal and choosing the different you can choose from here, right? So what amplitude you want to keep? For that amplitude, you can choose. Let's say I'm keeping a maximum amplitude. So this will be your amplitude modulated signal. So what is happening? Let's see. Carrier signal will be having the highest amplitude when the highest peak of the signal will be there. Then it will be reduced. See, the amplitude of the message signal is continuously reducing up to here. So here also, see, carrier signal amplitude is continuously reducing up to here. Then after this point, again amplitude of the message signal is increasing, so carrier signal amplitude will also increase up to this point, right, up to this point. And after this point again it will be reducing up to this point, right? So what is happening, carrier signal amplitude is following the shape or following the amplitude of the message signal. That's why you are getting this type of signal. So this is known as carrier signal. This is known as message signal, baseband signal, modulating signal, and this signal is known as modulated signal, but amplitude modulated signal. Is it clear, everyone? Why I put it this animation, so that you can see the, by using the different frequencies, right? If you will keep the different frequencies, then you will see the amplitude modulated signal into it. Is it clear to everyone how amplitude modulation is done? Everyone, are you listening? Or should I ask you the question? Okay, so okay, everyone is agree. So if you are able to understand this animation, then let me show you one of this video. Not required. Both videos are not required. Let me show you one video.
Writing's not that easy, but Grammarly can help. This sentence is grammatically correct, but it's wordy and hard to read. It undermines the writer's message, and the word choice is bland. Grammarly's cutting-edge technology. What is amplitude modulation? That is AM. When the amplitude of high-frequency carrier wave is changed in accordance with the intensity of the signal, this process is called amplitude modulation. In the amplitude modulation, only the amplitude of the carrier wave is changed. The frequency and the phase of the carrier wave remains constant. The first visual shows the principle of amplitude modulation. The diagram also shows the audio-electrical signal of frequency Fs. The second visual shows a carrier wave of constant amplitude with frequency Fc. The third visual is the amplitude modulated wave. It is to be noted that the amplitudes of both positive and negative half cycles of carrier waves are changed in accordance with the signal. Thus, the amplitude of the modulated wave possesses the frequency of audio signal waves. Explain frequency modulation, that is FM. When the frequency of carrier wave is changed in accordance with the intensity of the signal, this process is called frequency modulation. In frequency modulation, the amplitude and phase of the carrier wave remains constant. Only the frequency of the carrier wave is changed in accordance with the signal. The frequency variation of the carrier wave depends on the instantaneous amplitude of the signal as shown. When the signal voltage is 0 at A, C, E and G, the carrier frequency is unchanged. When the signal approaches its positive peaks at B and F, the carrier frequency is increased to maximum as shown by closely spaced cycles, but during the negative peak of signal as at D, the carrier frequency is reduced to minimum as shown by widely spaced cycles. The louder signal causes greater frequency change in modulated carrier as indicated by increased bunching and speeding of the waves as compared with relatively weaker signal. The frequency of an FM transmitter without signal input is called the resting frequency or center frequency F naught, and this is the allotted frequency of the transmitter. When the signal is applied, the carrier frequency deviates up and down from its resting value F naught. The change or shift either above or below the resting frequency is called frequency deviation, del F. The total variation in frequency from the lowest to the highest is called carrier swing, CS. Hence, carrier swing is equal to 2 into frequency deviation. So 2 into del F. For the purposes of FM broadcast, it has been internationally agreed to restrict maximum deviation to 75 kHz on each side of the center frequency for sounds of maximum loudness.
So everyone is getting the noise. I don't know why it is coming. Or right now it is okay, or still it is, you are getting a noise. Okay. So just let me refresh the page. Just wait for a minute. Hello. So what is the status? Are you getting a noise? Hello. Can anyone give the feedback? Are you getting a proper voice, or still you are getting the noise? Yes.
When we are getting proper voice of yours, there is no noise.
Okay. Okay. So right now there is no problem. Okay, fine. Okay, so let me continue with it. Okay, so in the amplitude modulation, how we will design amplitude modulator block at the transmission side. Okay, so at the transmitter side, what we can do is we will use a simple multiplier block. A simple multiplier block is a modulator in which one of the input will be the baseband signal, that is your input signal, and the second will be your carrier signal, that should be of the high frequency than this much, right? So at least you have to take care about the frequency of the carrier should be high than the message signal, then and then it will be it will give you the advantage. Okay, so by using one of the RF oscillator is the radio frequency oscillator, and radio frequency is in megahertz, right? So that's why that is also known as high frequency oscillator. So high frequency carrier signal will be generated from here. Message signal will be inputted to the one of the input of the modulator, and output of this modulator is your amplitude modulated signal. But as I told you that whenever you are transmitting your modulated signal through the transmission medium, either it is wired or wireless, then attenuation can be there. Right? I'm saying that it can be there. So if you want to amplify the signal at the receiver side, then also you can amplify, or before transmitting, if you want to amplify, what will happen? You will get some modulated signal, let's say of the 2 volt, right? And if your signal wants to travel a long distance, and if you want to amplify the signal and then you want to transmit it through the antenna, then you can amplify it first, then you can transmit it through the antenna. It depends if you want to amplify it or not. It depends on the amplitude of baseband and carrier signal also. So The same amplitude modulator, it is given as a signal in form of signal also. This is the modulated signal, this is the high frequency carrier signal. So modulated signal will be something like this. You have already seen this in the previous animation also, and we will see in the multisim also, don't worry.
I can see your screen.
Okay, you are not able to see the screen, sorry. Actually I have refreshed the page, no, that's why. Okay, so I have continued with this one. AM block diagram. Now you are able to see the screen, right?
Yes, ma'am.
Okay, so I have started with this block diagram in which this is the modulator circuit is a simple multiplier in which one of them input is the baseband signal, second input is the carrier signal. So modulator will modulate the signal, or you can say superimpose the carrier with the modulating signal. And if this signal is having the low amplitude, then it can be amplified by using the amplifier circuit, and it can then travel to the transmission medium, or it can be wireless, so you will transmit it through the antenna, right? Generally, whenever you are transmitting the signal will be in form of electromagnetic waveform. Okay, so you are transmitting the electromagnetic waveform by using the antenna. Now just a minute. Okay, so this is your modulator or multiplier block, which will multiply or superimpose these two signal, modulating and carrier signal, and you will get this type of modulated signal. You have also seen this waveform in the previous case in the animation also, and this is your final output what you will receive at the receiver side, where after demodulation you can receive the original message signal. So this is amplitude modulated signal, where the maximum amplitude is this one, right? And generally it has been proven that the maximum amplitude is the addition of two amplitudes, addition of the modulate amplitude of the modulating signal plus amplitude of the carrier signal. It means, let me tell you, this is the amplitude of modulating signal, that is AM. This is the amplitude of carrier signal, that is AC. So in this, highest amplitude you will receive is AM plus AC. So maximum peak of the amplitude modulated is AM plus AC. So same thing is given over here. You will receive AM plus AC is the maximum amplitude, and minimum amplitude is this one. So it is not written over here, but let me tell you that minimum amplitude is AC minus AM. AC minus AM. So carrier amplitude minus modulating signal amplitude. This is the maximum amplitude at the negative side. Envelope of the modulated signal are two. One is this positive envelope and second is this one negative envelope. Both are same. The only difference is this is starting from the positive cycle, or you can say that this is starting from the 0 degree phase and this is 180-degree phase. But both are same. So both are your information. Anyway, both are the information, right? So you have to see in detail that why they are transmitting both the envelopes or single envelope. So both type of techniques are there in the amplitude modulation scheme. Now very important is modulation index in here, in this also, that is in amplitude modulation. We have seen the modulation index in the ASK, FSK, PSK also, that is in form of D. Here also we are going to see the modulation index, or it is also known as modulation depth. So modulation index is nothing but the ratio of amplitude of the modulated signal or message signal upon amplitude of the carrier signal, AM upon AC. Modulation and index can be defined as capital MI or small m or mu. Right, in another different books they have used the different symbol for the modulation index. AM is the maximum amplitude of the message signal. AC is the maximum amplitude of the carrier signal. We have already seen this. So the maximum amplitude of the message signal must be less than the maximum amplitude of the carrier signal to avoid any distortion in the modulated signal. So as I told you that the frequency of the carrier signal should be high compared to the message signal frequency. Same way, amplitude of the carrier signal should also be high compared to the message signal, right? So if you will keep this type of things, then you will not get any distortion at the receiver side. So three types of modulations can be there by using the modulation index according to the value of the modulation index. The first is perfect modulation. Perfect modulation is the one in which modulation index equal to 1. I repeat, perfect modulation is the one in which modulation index equal to 1. Under modulation is the one in which modulation index is less than 1. I repeat, under modulation is the one in which modulation index is less than 1. And over modulation is in which modulation index is greater than 1. So equal to 1, perfect modulation, less than 1, under modulation, and greater than 1, over modulation. Let's say modulation index is equal to 1. If modulation index is equal to 1, then what will happen? AM will be equal to AC. So I told you that maximum amplitude of the AM signal is AC plus AM. So you can say that if both are equal, then it will be twice of the amplitude of the message signal. And this is the minimum amplitude is AC minus AM, I told you, right? So if both are equal, then AC minus AM is 0. So it means this envelope will touch the 0 line, right? So minimum amplitude of this envelope is 0 volt, and the maximum amplitude is AC plus AM, or you can say this twice of AM or twice of AC, both will be valid. Okay, so this is done in the perfect modulation, where the signal, envelope signal, is touches the 0 line, or you can also say that carrier signal is reaches to 0, and then again it will start increasing, again it will start decreasing, and reaches to 0, again it will start increasing, and so on. Okay, so this is the example of perfect modulation. Now, if it is under modulation, so if it is under modulation, then what will happen? That mi less than 1, right? Under modulation means what? That modulation index will be less than 1. So what will happen? That is AM will be less than AC. Why? Because this is the equation. Mi equal to AM upon AC. When it will be less than 1? When AC is greater than AM. So AC is greater than AM, then modulation index will be less than 1. So AC plus AM, AC plus AM is the maximum amplitude, but AC minus AM, here AC greater than AM, right? So AC minus AM is some positive value, neither 0 nor negative. It will be some positive value. So your envelope will not reach to 0. Your carrier signal is start decreasing the amplitude, but after some point of decreasing, again it will start increasing. It will not reach up to 0 in the under modulation. So this is the modulation index that is less than 1. So you will get the under modulation process. Okay, so when the maximum amplitude of the message signal or modulating signal is less than the maximum amplitude of the carrier signal. Message signal maximum amplitude equal to 2 volts, let's say, and AC equal to 4 volts. AM equal to 2 volts and AC equal to 4 volt. So what will be the modulation index? 2 upon 4, that is 0.5. So in this case, MI is less than 1. And the last case, that is over modulation. So over modulation, can anyone say what will happen in the over modulation? What will happen to the waveform in over modulation? Can anyone assume? In perfect modulation, the line will touch the 0 line. In under modulation, the line, this envelope will not reaches to the 0. So in over modulation, what will happen? Yes.
Then the value will be
Yes,
negative.
correct. So in this case, over modulation case, your modulation index is greater than 1. It means AC is less than AM. Sorry, yes, AC is less than AM, or AM greater than AC. Okay, so AC is less than AM means AC minus AM is negative value. So your envelope will go to the negative axis. So let us see that waveform. See, you will get like this. Positive is AC plus AM, no problem, but negative value will come here because AC minus AM equal to minus something. So AC minus AM is negative value. So your both envelopes will overlap each other, right? This is the case of over modulation. One example is given. AM is 6, AC is 4, so 6 by 4 is 1.5. So if modulation index is 1.5, that is greater than 1, then this type of over modulation will occur. Okay, so three types of modulation index can be there in the amplitude modulation. So what are the applications of the amplitude modulation? Where amplitude modulation technique is being used? Okay, so we will see this after 2 minutes break. I think you require a 2-minute break because we are starting from, yeah, see, Ashish has already asked me. What about break, ma'am? Okay, so take a 2-minute break and we will resume it after 2 minutes. Okay, so can we resume now? Hello, everyone. Completed your break, everyone? As expected, Ashish. But anyway, I think we should resume now.
Ma'am, 2 minutes is
Yes,
completed. So
yes,
fast.
it is completed. 2 minutes is a very small time.
Not completed, ma'am. I am watching the watch.
What happened, Ashish?
I am watching the watch, ma'am. Not completed two
No,
minutes.
it is already completed. I am also watching the watch.
Ma'am, 10 seconds are
What,
left.
ma'am? In my watch, there is 1 minute.
Okay.
1 minute left, ma'am. Everyone watch.
Okay, okay. After half an hour, I will again give you a break. So let us resume now.
Okay, ma'am.
Okay, fine. So we have completed up to here, and we that right now, what is the applications of the amplitude modulation is also equally important. That in which type of medium or which type of applications or places field where you are using this amplitude modulation. So first is the airband radio, right? It is used in the aerospace industry. So in aerospace industry, they are using a special radio, right? In that they are using the amplitude modulation technique. Second is the broadcast transmission. So it is used for the broadcasting either short or medium or long wave bands, right? Short, medium, or long are nothing but the wavelength, right? If the wavelength is small, wavelength value is small, then that is known as short wave band. Okay, if wavelength is medium, then it is known as medium wavelength or long wave band. Okay, so if you are transmitting the different type of wavelength data, wavelength signals, then in the broadcasting, then you can use this amplitude modulation techniques. So last is the single sideband. Okay, single sideband is very important because I already told you that whenever you are receiving this type of signal, then two envelopes will be there, and both are information. One with the 0 degree, one with the 180 degree, but both are the information. So this information you can receive by using only one envelope also. Then why you are sending the two envelopes and resting the power? Right, whenever you are sending this type of signal, obviously the power requirement will be high if two sidebands are there instead of one, right? So single sideband techniques are also there in the amplitude modulation. So single sideband techniques are being used in the in the form of single sideband is still used for the high frequency radio links. Okay, so high frequency radio links are there, they are using the amplitude modulation, but not the full or you can say double sideband. They are using the single sideband. So generally, amplitude modulation can is also known as double sideband full carrier. Amplitude modulation is also known as DSBFC, double sideband full carrier. But what is the meaning of double sideband full carrier? That both sidebands plus carrier you are sending through the transmission medium. So you will require that much power. Now, if you will send only sidebands, not carrier, so that technique is known as double sideband suppressed carrier (DSB-SC). Then, if you are sending only one sideband, right, then that is known as single sideband without carrier. Okay, so you are suppressing the carrier also, you are suppressing one sideband also. So that is known as single sideband. But in some of the applications, they have recognized that single sideband sometimes are losing some of the information, so they are using the last modulated, or you can say the you can say the improved version of amplitude modulation, that is known as vestigial sideband. In vestigial sideband, they are sending one full sideband and some portion of the another sideband, one full sideband and some portion of the another sideband, so that information cannot be lost. So for detailed study about these all techniques, you have to study those all techniques into the detail. And actually some EC students are studying this techniques as one of the subjects, so you can understand that this is the biggest you can say the syllabus, right? So that is not in your syllabus in detail, but they are saying that amplitude modulation can have the different forms: double sideband suppressed carrier, double single sideband, and vestigial sideband, right? So these are the some of the techniques which are being used in the different applications. So here we are looking at the three main applications: airband radio, broadcast transmission, and the high frequency radio links, but in form of single sideband. Advantages of the AM, and what which are the disadvantages? Advantages are simple modulator circuit will be required in amplitude modulation. It is the cost effective, right? So simple modulator circuit means what? You are not making a complex circuit, so cost will automatically be reduced, right? So cost effective. Third is it can be demodulated using a circuit consisting of very few components. See, I will tell you that in modulator and demodulator, very low a small number of components, less number of components will be used. For example, in modulator, we have already seen only one multiplier will be used, right? One multiplier will give you AM. And same way, in the demodulator also, only one low pass filter and diode will be used, and you will get the demodulated signal. So very less number of components are being used at the modulator and demodulator. So three advantages: simple circuit, cost effective, and the less number of components are being used. And the disadvantages of AM is, first, poor performance due to noise. So whenever you are using the amplitude modulation, the noise can be there. So performance of this circuit are not that much good. Not that much good for all applications. In some of the application, it is working good, no problem. But in some of the application like long distance communication, sometimes the circuits are not working properly, these are not giving you the good performance. Second is inefficient use of transmitter power. As I already told you, that whenever you are transmitting the signal, you are, if you are transmitting both sidebands and the carrier signal, then you are wasting the power, right? So kindly suggest some proper technique in which you are getting the all information without wasting the power, right? So here the amplitude modulation is being used in the all different forms, in which some of the techniques are using the power in an effective manner, and some of the techniques are not. Okay, and the third disadvantage is it is not efficient in terms of its use of bandwidth, requiring a bandwidth equal to twice that of the highest audio frequency. So they are saying that here they are not utilizing the bandwidth properly, right? So this techniques, amplitude modulation, is not utilizing the bandwidth properly. So how you will say that bandwidth utilization is proper or not? So bandwidth utilization actually again give you the proper utilization by form of Nyquist criteria. Okay, so here they are saying that Nyquist criteria are not being followed well, and you can say that if you are using the let's say message signal of 20 kilohertz, if you are using a message signal of 20 kilohertz, if you want to transmit it through the amplitude modulation, then this technique is using twice the highest audio frequency. It means twice of 20 kilohertz. So it will require high bandwidth, very high bandwidth. Actually it is not you can say that necessary, then also this technique is using the higher bandwidth. Okay, so requiring a high bandwidth that is equal to twice that of the highest audio frequency. So these are the some of the advantages and disadvantages of AM, and I already told you the form of AM. Different forms of amplitude modulation are being used. That is DSB-FC, double sideband full carrier, double sideband suppressed carrier, SSBSC, single sideband suppressed carrier. One more technique is there, that is vestigial sideband. It is not mentioned here because it is the combination of these two. Okay, some portion of the SSB, one sideband and one whole sideband is covered into that. So it is the combination of these two. So it is not covered here. But yes, that is the fourth type. Now, if you want to design a modulator and demodulator circuit into the multisim, then what you will do? Multisim modulator is very simple. You have already seen that multisim modulator, that multiplier. You will give one analog signal or message signal, and second will be your carrier signal. So message signal and carrier signal will be applied to the multiplier, and you will get the modulated signal. So let me show you this circuit. Okay, see here. Multiplier is having two inputs. One is the 5 volt 100 hertz. 5 volt 100 hertz. So see here, the frequency is 100 hertz, voltage is 5 volt. And second is function generator, which is having 1 volt and frequency is 1 kilohertz. Right? So you can keep this as also, let's say 10 volt. So high frequency, high amplitude. Okay, so this is the carrier signal of 1 kilohertz 10 volt amplitude. If you will give this both signals to the multiplier, one is your message signal and second is the carrier signal you are generating from the function generator, or you can generate it through the oscillator. Anything will be okay, right? So this is your carrier signal and this is the information or message signal. Now at the receiver side, at the transmitter side, whenever you want to transmit the signal after multiplier, how the modulated signal will be there. So let us see that just a minute. Or first of all, let me show you the connections properly. So we want to see all the waveforms. So let's say first I'm connecting the message signal with the first channel of the oscilloscope. Second, I am connecting the carrier signal with the second channel of the oscilloscope. And third, that is modulated signal from the output of the multiplier. Okay. So can you see the multisim screen, everyone? So see here, the first yellow color signal is channel 1. Channel 1 we have connected with the message signal of 5 volt 100 hertz. So 5 volt 100 hertz signal is your message signal. It cannot travel a long distance, so we have connected one carrier frequency signal, that is from the function generator. Okay, 1 kilohertz 10 volt. Now, if you will do the multiplication of these two signals, you will get this type of signal is known as amplitude modulated signal. Amplitude modulated signal. Now, let me tell you amplitude modulated signal, how it will work. That if carrier signal is having the high amplitude than the AM, that is AC is greater than AM, then it is known as under modulation, right? That's why it is not reaches to the zero line. But let me show you the different possibilities. It is 5 volt peak to peak signal, right? So to make 5 volt peak to peak, I have to keep it 2.5, right? 2.5 peak voltage. 2.5 is the peak voltage. So 5 volt peak to peak will be there. So both are equal now. AM equal to AC. Just a minute. Okay. So if AM equal to AC, then see the amplitude is reaching to zero line after every one cycle of the sine wave. Amplitude is reaching to zero, right? So AM equal to AC means modulation index equal to 1, and modulation index equal to 1 means it is the perfect modulation. So you will get AC minus AM equal to 0. So your envelope is reaches to zero line. Again it is starting with the positive cycle, again it is reaches to 0, and so on. Same for the negative envelope. And the last possibility is if AC is less than AM, AC is less than AM. So let us keep this amplitude as smaller than this one, right? It is 2.5 volt peak. Here I am keeping 1 volt peak. Just a minute. This. Oh, it is not. Yeah, it is going to the negative also. So okay, now let me show you just a minute. Okay. So see in this waveform, if you will draw the envelope, then you will draw the envelope like this, right? Which will go to the negative cycle also. So it will show you that over modulation can be occur if you will keep the different frequencies. Now you have to keep two things into mind here. That one is your amplitude of the frequency of the carrier signal must be higher than the frequency of the carrier signal is 1 kilohertz, should be higher than the frequency of the message signal for sure. Then and then you will get the modulation or advantages of modulation. Otherwise, no need to superimpose. We are doing it, or we are making it superimposing only for getting the advantages of the modulation. Just a minute. Let us keep the high difference. Okay. So see, this type of signal, modulated signal, you will get at the output of the multiplier. And this will be again, see, it can be simply designed, it can be simply demodulated by doing the, making the envelope of this signal. Simply making the envelope of this signal. So any doubt in this circuit? That simple multiplier we are using, which will multiply carrier signal and the message signal together, and you are receiving this type of signal. This is the output of modulator, AM modulator. Any doubt to anyone? Have you shown us this simulation before? No, I haven't shown this simulation because we have done the digital modulation only. Analog modulation, we are doing it today only. And why again? Ashish, same thing I'm telling you. Right? We have not seen this type of simulation in the digital modulation technique. That's why. Maybe you have read it. Yeah, maybe you have read it before in the book or somewhere else. But this type of simulation we have not done in the multisim. Now, the demodulation. Demodulation is equally important. So, first of all, before doing the demodulation, let me tell you there are so many techniques to do the demodulation, right? But those all different demodulation techniques are for the different form of AM. For DSB-FC, there are different demodulation technique. For DSB-SC, there are different demodulation technique. For SSB, there are different demodulation techniques. So here we are going to see the demodulation for only AM. AM is equal to DSB-FC. Okay, so double sideband full carrier signal. How this signal will be demodulated to original message signal at the receiver side, right? That we are going to see here. So demodulation is the reverse process of modulation, and the process of detection provides a means of recovering the modulating signal from modulated signal, right? Modulated signal is your AM wave, superimposed signal. And from this imposed signal, I want to receive the original low frequency message signal or baseband signal. Since the envelope of an AM wave has the same shape as the message signal, independent of the carrier frequency and phase, demodulation can be accomplished by extracting the envelope. That is the one of the method. So two methods are there to demodulate the signal. First is the envelope detector and second is the product detector. Two techniques are there, envelope detector and the product detector. So let us see the first one, envelope detector. In the envelope detector, what we are going to do, see, either we want to detect the positive envelope or we want to detect the negative envelope. That is for sure, right? Because both are giving me the original signal. So if you are if you want to detect the positive envelope, then you have to put the diode in the forward bias. So what will happen in the forward bias? In forward bias, positive cycles will pass through it. Positive value, whenever positive cycle will come, diode will be in the forward biased or it will be short circuited. So it will directly go to the capacitor. What capacitor will go? Capacitor will do, capacitor will charge and discharge, right? So capacitor will charge whenever positive value will come to it. And whenever negative value will come to it, it means whenever diode is in reverse biased, right? So this will be in the open circuit. At that time, this capacitor will discharge through the resistor and you will get the output. Same way, you can do the opposite thing also. How opposite thing? Because see, you are receiving the negative envelope also. So I will show you in the multisim also that both type of techniques are valid. If you will use the diode in this direction, then also you will get the message signal, and you will, if you will use the diode in the reverse direction, then also you will get the envelope, but 180-degree out of phase. You will get the message signal for sure, but in the phase difference will be there. Okay, so that we will see in the multisim also. An increased time constant RC results in a marginal output follows the modulation envelope. See here, RC is the I already told you in the I think one of the experiment that RC is also denoted as the time constant. Time constant for if you are saying that capacitor is charging and discharging, so charging for how much time, discharging for how much time. So the time of the capacitor charging and discharging depends upon this RC time constant. And this RC time constant also defines or give you the frequency of the message signal, right? So you will receive the frequency of the message signal same as the input signal if you will keep the RC value in such a way. Okay, so we will see in the multisim that if I will change the R value or C value, then which type of waveform we are getting. Okay, so this is the demodulator circuit in the multisim. Okay, we will see this demodulator circuit. See here, both diodes I have connected in the positive direction also, in the negative direction also. Both will give me the different envelope, right? So we will connect one by one and we will check the output. Okay, so you can just do one thing, take a 2 minute breaks, and then we will do the demodulator circuit. And I think after demodulator, I will ask you some question, and today's session will be over. Yeah, Ashish. I already know it. So take a break of 2 minutes and then we will resume with the demodulator circuit. Okay, so can we resume now? Okay, fine. Uh, Let me show you. Okay, so this is the demodulator circuit. Let us directly go to the multisim and let me show you the circuit. See, here again you can apply the different voltages or frequencies, whatever you want. For example, okay, sorry, this is kilohertz, 1 kilohertz, and let's say I'm applying the same amplitude so that I can get the perfect modulation. 5 volt is there, so 2.5 volt in the carrier signal. This is your message signal. Multiplier will do the modulation. So this is the part up to which you are doing the modulation that you have already done in the this circuit. Okay. So after this, you are getting the modulated signal, amplitude modulated signal. Now you want to recover the original message signal like this at the receiver side. So what you will do, you will pass this modulated signal through the diode in this direction. So you will get the positive envelope. We will do both of this thing. Don't worry, right? So you will pass this signal through the diode. Then capacitor will be charged in the positive cycle. It will be discharged in the negative cycle, and you will receive the output across the R1. Okay, ground is already connected. No need to connect it back, or you can connect it with the ground also. No problem. Okay, so across this R1 you will get the output. Now let me connect again. First is with this, that is your modulated signal, and second is the demodulated signal. So channel 2 is connected with the R1. Just a minute, I'm just setting the RC value so that you can get the filtration also. Okay, okay, I'm not getting any much difference into this. Okay, so can you see this now? If you are changing the RC value in such that you can get the signal after this RC value is almost your original
Ma'am,
message.
your screen.
Yes, screen.
Your
Sorry,
screen.
sorry. Just a minute. See, here also you are not getting this smooth negative cycle. Do you know why? Because it is simply showing the capacitor charging and discharging. If you will keep this value, let me show you. If this value of R will be 1K, let's say high value, then even this signal you will see at the output is almost like capacitor is charging and discharging. See, capacitor is charging, and after that you will get the discharging of the signal. See, it is same like charging and discharging. If you want to smooth it out, then you have to change RC constant so that it can work as a low pass filter, and low pass filter will smooth on your output, right? So you can change this R value and you can check, right? You can check the R and C value and you can check that how your output is and which type of output you want. So is it smooth or not? That's what you want to see. Yeah, there are some spikes are there just because they are not that much filtered. The edges are not that smooth. So by putting a proper low pass filter, you will get the original message signal like this. Right, so this is only the positive envelope. You are getting the positive and negative cycle in one slop of this. It is again charging and discharging only, but somewhat smoother than the previous case. It is again a charging and discharging of the capacitor only, but it is more smoother than the previous one in which the value of R1 was 1 kilo ohms. So you can demodulate your AM signal by using the low pass filter and the diode. If you will keep this diode in the negative direction, let me flip this. If you right click, then you can flip it horizontally. Simply delete these connections and connect it to. Sorry, this only one should be connected to. See, you are getting the same but negative envelope. Are you getting this? You're getting the same thing, but the negative envelope you will get instead of positive. So no difference if you are putting the which of the diode, because you will get the information for sure. But either in one condition you will get the positive envelope, and in the second condition you will get the negative envelope. Negative point depend on the value. Which value, Ravi? We're talking about which value?
Ma'am, whenever our signal going on negative direction, then
Yeah.
that negative direction depend on value. Then how many value we are giving? Like
No, even positive value is also depend upon the value of RC. Positive is also depend upon the value. Why? Because see, I already given you the example that if you will keep this resistance in a different value, then even positive at that time also positive waveform was not that smoother. Let's say I'm putting it 10K. Just a minute, guys. Even this, that is not charging and discharging is proper, because charging time will be very high. RC is the charging time. If R is very high, your charging time will be very high. That's why you will not get the proper waveform. See how you can say that positive cycle is there or not. Positive cycle and negative cycle both are inaccurate here. But if you want to make it smoother, if you want to convert it in form of sine wave, right, smoother sine wave, then you have to keep the RC value in such that it can smoothen your waveform.
Ma'am,
Yes.
suppose that whenever in any condition positive and negative value would be same, then what
Mhm.
would be happen?
Positive and negative value will be same means I'm not getting.
Ma'am, what I say?
You want to say that positive and negative both should be smooth, right?
Maybe like yes, ma'am. Explain now.
Yeah. So if you want both as a smooth, then you have to keep a very small changing. You have to do very small changes in the RC value, and then you have to check that if I'm doing this small change, then are we getting the proper smoothness or not? And then again change it by 50-50, adding and subtracting. You can get the value, get the smoothen waveform. But you have to check it for everything. I'm directly changing 1K to 100, right? You cannot do that much big changes. You have to do small changes and you have to check. So it's a filter, it's a type of filter, or you can change the type of filter also. This is a simple RC passive filter. You can use the good filter if you want the good changes or good smoothness into the waveform. But by using this diode in the different direction, you can get the different envelope, either positive envelope or the negative envelope, as we have seen. Okay, and you will get the message signal. Second is the product detector. So I think we will start this product detector, and a little bit is pending. Product detector is the second demodulation technique, and some of the questions we will see right from the amplitude modulation in the next lab. Okay, so till then, I think in the next Tuesday onwards, there will be Janmashtami holiday. Okay, so I think next clip will not be there. So next to next lab will be there. We are facing bad weather condition due to which we are facing. Yeah, no problem, no problem. So everyone, you can write your enrollment number for today. We will continue from here in the next to next lab. Next lab will be the holiday. I hope you are aware about your holidays.
Ma'am, one last question, ma'am.
Yes, Ravi.
About modulation. Suppose that I have two antenna
Yeah.
from